All right, welcome back everyone to week 3, day 2, morning algorithms. All right, this morning we're going to write a function that takes in non-empty array of distinct integers, so they all have to be different. Like this array here has 12, 3, 1, 2, -6, 5, -8, and 6. None of those integers are the same. And an integer representing a target sum. So the target sum in this case would be 0, which, and so it's a lot like yesterday, but it's slightly different. The function should find all triplets in the array that sum up to the target sum. All the triplets in the array that sum up to the target sum. So now instead of finding 2, we're looking for 3 triplets. And return a 2-dimensional array of all these triplets. So you have to return a 2-dimensional array like this. So here's an example of a triplet, -8, 2, and 6. Another one would be -8, 3, and 5. And the third one would be -6, 1, and 5. The numbers in each triplet should be ordered in ascending order, and the triplets themselves should be ordered in ascending order with respect to the numbers they hold. Okay. If you can't get this part and you only get through this part, then you're still doing well. This is like extra work. If no 3 numbers sum up to the target sum, the function should return no 3 numbers sum up to the target sum. Okay, if there's nothing that adds up to that target sum, then you have to make it 0. Okay, so you're looking for triplets. They have to be distinct. And then once you are able to get an output, then order this output in ascending order. Okay.
Can we
All
use
right.
nested for loops, or do you want us not to?
Well, if you cannot think of any other way beside a nested for loop, I won't say don't use it. For the sake of solving it, at least do it with the nested for loop. But there is a way to do it without a nested for loop. And so I want you guys to think outside the box. We saw it done yesterday by Ethan. He had 2 separate for loops. But think of a way you can do this without doing nested for loops. So you have to do something similar that you did yesterday. Maybe have a place where you save data for yourself to check if you already have made some pairs or matches to, get those 3 triplets together. Okay, so this one's a little bit harder. I wanted to, since you guys solved yesterday's, and yesterday's was easy, medium, but a little bit more on the difficult side as well. But this one here is a little bit more difficult, so I want you guys to keep going on with the challenges until you feel like, you've reached a point where you understand how difficult things can increase. But that's not the point of this. I just want you guys to have a good challenge, and I'll be in the rooms here to guide you guys if you get stuck. Okay. Anyways, let's get started. I'm going to break out into groups. Here we go. The last cohort was able to solve this one, so I have belief in you guys here. All right, welcome back, everyone. Let's provide our solutions. So who would like to volunteer to show how they got theirs working?
I don't mind going.
All right, let's see that solution roll.
All right, so we did it with a bunch of for loops. We could not figure out how to do it with just one for loop. So in the beginning, array sort sorts it into least value to greatest, and then actually we made a container to hold the values, right? So as it runs, it's gonna check individually, which ones, what sums add up. It's gonna push it to the container, and then at the end of it, it's gonna check if the container length is 0, that means nothing got pushed to it, so no sum can be found. And then if not, it will just return the container in ascending order.
Okay. So you have a triple for loop. You have X, Y, and Z. And if they add up to the target, then you push to the array that's called container, right? And if it's empty at the end of these for loops, if nothing added up to the target, then you turn. If not, then you tried it with different numbers?
Yeah, we tried it with, well, just 2. I did the example number, and then just to put whatever to 100 to make sure that it pushed out no sum.
Okay, cool. That works. Okay, how many other people found it using this similar type of solution? Any other groups that had something different than this?
Ours was exactly like that.
Yours is exactly like that. Okay. And I
Really
noticed
copious.
most people did triple for loops. Did anyone do it come close without using a triple for loop? Okay. Well, I'll go ahead and share my solution. I noticed that David and RJ's team were close to this type of solution, so they were looking into something like I'm about to show, but still a little off target, but we'll show here what we need. All right, so pulling it up so I can share my screen. Okay, so I think I'll go through it quickly, just talking about it, then I'll try and T-diagram it quickly here as well. So I'm almost close to the end of the hour. Okay, so we have this thing here. This will sort the array, and we need the array sorted to do it with just one for loop. I would usually assign that you guys study how this works and why it's written this way to make the array sorted. We need it sorted from negative numbers on the left to positive numbers on the right. If you use just a regular array.sort, it won't give you this type of value. You would have to use something like this to give the desired result that we're looking for. Negative on the left, positive on the right. Okay, so this sorts the array negative on the left and positive on the right. Okay, then I make this variable called triplets. This will hold the triplets. Then I have one for loop. As you can see, that's the only for loop in the whole function. Here it is. I start with I equaling 0. And I go through the length of the array minus 2. Instead of minus 1, or just array.length, I'm saying go through the array length, but except 2 spots at the end. So this will be the second to last position on the array, right? Because minus 1 will be the last position of the indexes. Minus 2 will be the second to last of the indexes. So we increase by 1 each time. And the reason why we do minus 2 is because we have a couple variables here that will point to certain places in the array. So let's say we take this array here, we sort it, and it would be -8, -6. So let's write this out. Might as well start T-diagramming. Okay, so -8, -6. What's the next one? 1, 2, 3, 5, 6, 12. Okay, I'm just adding a little space so I can put my pointer on each number and you guys can see what I'm pointing at. So stay with me here. Okay, here's the array. And we are saying let left be I plus 1. We said I was going to be 0. So here's I. I is right here at 0. Left is going to be here. I plus 1. L for left. And then right is going to be array.length -1. So I'll make an R here for right. So this is going to be at the end of the array. So that's why we are going -2, because we've already accounted for the last index of the array. So we only need to cycle I to the second to last, where R hasn't touched yet. And here's what we're going to do with the sorted array. We're going to say, while left is less than right, at some point left may be equal to right or greater than right, but as long as left is less than right, then we're going to say, this is another word for variable. So is let. Okay, we'll explain what these mean later, but this is just another word for variable for now. Current sum equals array at I plus array at left plus array at right. So we have a current sum always being held of all 3 pointers, I, left, and right. And if at any point the current sum is equal to the target sum, so if I, left, and right at their current position equal the target sum, and the target sum is what we've asked to receive at the beginning. So if at any point it's equal to our target sum, then we push to triplets this variable here, those 3 positions, position at I, the value at I, the value at left, and the value at right. We push an array to that triplets array that holds all 3 values. And then after that, we increase left by 1. So we move left from its position above -6. And then we move it here. And then right, we move as well. So that's if we hit this if statement. Okay, we didn't actually test it, but we're just doing like a example of how the pointers would move around. Okay, else if current sum is less than target sum, then we just increase the left one. If it's less than the target sum, we increase the left to try and get closer. We get a little bit more, make it a little bit increase left, that we know that it's going to increase from left to right in ascending order. So we can increase left to the right and get a higher value of the three together. Else, if current sum is greater than target sum, then we decrease right. We try to decrease the value. Okay, so we're moving left and right to try and get a feel for how we can get to that target sum. If it's less than the target sum, if our current sum is less than, then we increase left. If it's greater than, then we decrease right. So we check every value with I being at 0. And then after we do all that, then we increase I. We move I to the right. And then we do this process all over again. Left becomes I plus 1. Then right becomes array.length minus 1. So we move right back over to the right here. Okay, and then we check again. While left is left, then right. Then we check all the values. Then at the end of this for loop, we return the triplets. I don't think I wrote the else in here to return the answer if it wasn't there's no sums. But this is how you would check all the sums. I would just have to write an else in here with just one for loop.
So what if the right is not, what if the left is not less than the right?
What if the left is not less than the right?
Yeah, in line 82.
So when we start with an array that's in a sorted order, left is going to be less than right every single time, as long as we have different numbers.
Oh, okay, because you sorted it at the beginning.
Yeah.
Okay.
That's why it was important to sort it at the beginning. Okay. Anyone have any other questions about this solution? It's it takes a little bit of practice, and I wouldn't have thought this solution on my first try. This is like a really well thought out solution because it only uses one for loop. It uses 2 pointers, left and right. And then it checks if left is less than right, then we check every possible combination. If it does match, then we move both at the same time. If it's less than, then we move the left. If it's greater than, we move the right. So, little different than a triple for loop, right? But now that we've seen this, we can know that we can do this if we ran into this problem again, okay? So, if we have no further questions, so we'll end this lecture now and then take a break before the next lecture. Okay, all right, let's go ahead and take our time.